Hi, this is Mr. Bear, and I'm going to be showing you how to go through this practice quiz that was given in class on Thursday. So, what we have is a series of problems that are asking you to convert between mass, moles, and particles. For all of the problems, you need to know that we use grams, which is a representation of mass, to represent how heavy something is. And how heavy something is can be converted into moles by using the periodic table. And the number on the periodic table gives us something called molar mass. This molar mass, which comes on the periodic table, allows us to convert mass to moles. And an example of that is, say I'm converting between 5 grams of carbon to how many moles of carbon there are. I would go to the periodic table, look for carbon, and see a number on the bottom, which is the mass number. That mass number tells us how heavy carbon is for 1 mole of carbon. And that's specific to carbon. So we use molar mass, that's what molar mass is right here, to convert between mass and moles. So this is part of what this practice test or practice quiz is showing you how to do, or at least testing you on, is how to go between these two. So there's also describing what we have before us in something called particles. Particles are how many individual things there are. Moles is how many groups of things. So a mole is always 6.022 times 10 to the 23rd, and particles are always the individual things, which is 6.022 times 10 to the 23rd, Avogadro's number in the stuff. So the conversion between moles and particles does not have to be looked up on the periodic table. It is something that is always this conversion factor right here. It's always this. And it's that many particles is always equal to a mole. So all of these questions have you going between mass, moles, particles, back and forth, back and forth. So what we're going to do is we're going to critique, we're going to actually grade together this student, who I could tell got most of her questions correct. Let's take a look at the first question. The first question is saying that you have 4.5 moles of sulfur dioxide. And it's asking for how many molecules you have. I can tell she made her first mistake. She shouldn't be writing question mark particles, because particles can be anything. They can be tacos, they can be people, bicycles, whatever else you want to call them, atoms, molecules, anything like that. In this case, we need to be specific. It's SO2, so we're counting molecules. So she started off by writing out the given. She knows that she's going from moles to particles, which means she's using this conversion factor right here. She put the moles on bottom to cancel out moles, and she unfortunately put atoms on top. SO2 is not an atom, that's a molecule. She has to be putting molecules in place of atoms. And of course keep molecules right here. Now I can tell that she got her answer correct, or at least relatively correct. Let's double check this. 4.5 times Avogadro's number 6.022 times 10 to the 23rd. We use the E button, and she got it correct. 2.7 times 10 to the 24th, and she has 2 sig figs in her answer, just like she started with. That's correct. But her units were wrong, and I need that correct. In the second problem, you're starting with atoms and going to moles. So this time we're going from here to here. You're still just using this conversion factor. So I see atoms down the bottom, good, because we're talking about neon. Moles on top, atoms cancel out. She does not have her answer in moles of neon. That needs to be there. Let's double check that she did the math correct. 12.8 times 10 to the 15th, divided by Avogadro's number 6.022 times 10 to the 23rd. And I'm going to convert this to scientific notation. So it's 2.13, that's 3 sig figs, just what you started with, times 10 to the negative 8. And there it is right there. That's correct. The next question is going from grams of nickel to moles of nickel. I'd like her to be writing what the substance is, by the way, here. So now she's going between how heavy something is to how many it is. So she's using molar mass that comes from the periodic table. It's nickel. So on the periodic table, she looked up nickel. And here's nickel here, and it says 58.69. So she put 58.69 on the bottom because that's how heavy 1 mole of it is. 1 mole on top, canceled out the grams. Math looks correct. I'm going to double check her on it. 1.4 divided by 58.69. And she has a correct answer of, she did not write it on scientific notation, but that's totally fine. Nothing wrong with that. 0.039. That is correct. Answer has the same number of sig figs as what we started with. Very good. We're good to go. Okay, moving on. Number 4. Number 4 has you going from moles of SiO3 to grams. So we're going from moles to mass. Again, gone from here to here, we have to use molar mass, which comes from the periodic table. But this time, it's SiO3. So she has to, there is no SiO3 on the periodic table, but there is silicon and oxygen. So what she did is she added up silicon plus 3 oxygens and got a molar mass of 76.09, which looks correct to me. And she's canceling out moles, so on top, she wants her answer in grams, so she has to have grams here. Everything looks fantastic. I'm going to double check her math, 28.09. Let me double check this molar mass, plus 16 times 3. That's correct, 76.09, which needs to be multiplied by 5.05. And she ends up with the correct answer in correct sig fig, so very good. Let's move on to number 5. Number 5 starts in grams and goes to molecules. Since we're going from how heavy to how many individual things we have 2 steps, which requires 2 fractions. So the first fraction is going from mass to moles. So moles on top, cancel out the grams. It's CH4, carbon's 12.01. There are 4 hydrogens, which each weigh 1.01. She took 4 times 1.01, which she got 4.04. Added these 2 together, she got 16.05. So there we go. This is the first step, which is converting between those grams to moles. Then once you're at moles, you're going to particles, so from there to there. So now you're using Avogadro's number. And since the question's asking for how many molecules, she shouldn't have atoms up here. She should have molecules. And this as well should be staying molecules. And the answer needs to be in molecules, not atoms, because CH4 is a molecule, not an atom. It's a collection of atoms. So that's correct, shows the moles canceling out. Everything looks fantastic. Let me double check the math for her. 2.34 divided by 16.05, enter, times 6.022, E23, and the answer is 8.78 times 10 to the 22nd. Unfortunately, she doesn't have this here. That's actually wrong. Unless this arrow is indicating I need to flip it to the other side. Nope, don't see it there. So what she needs to have done is she needs to have looked on her calculator, because you can sometimes miss this, that it says times 10 to the power of something on the far right of your calculator. So the correct answer is 8.78 times 10 to the 22nd molecules of CH4. Okay, moving on to the next one. Next question. Next question's number 6, and we're going between molecules and grams. Starting off with molecules, converting it to moles, because if we're going from particles, which is molecules, remember individual things, to moles, to mass, that's 2 steps. Notice here I quickly see the 2 steps that she's done. I see molecules being canceled out using Avogadro's number, that's correct. Then using the molar mass of nitrogen dioxide, which is 14.01, plus 16 times 2 gives us 46.01, which I'm going to double check that she did all of her math correct, doing the math right now in my calculator. And it ends up being 2.29. She needs to round this to what we started with, which is 1 sig fig, so the correct answer is 2 times 10 to the negative 22nd grams of NO2. Again, what she should have done is checked on the far right of her calculator, and she would have seen that there's scientific notation there when that's typed incorrect. So always double check that. Next question. You have 3 moles of tacos. How many tacos do you have? Well, how much stuff is in a mole? Well, it's always Avogadro's number, but the unit for Avogadro's number depends on what we're counting. What are the name of these individual things? Well, they're called tacos. So this will tell us how many tacos we have. The moles cancels out. We're left with the tacos. We got our answer. So it should be 3 times 6.022 times 10 to the 23rd. We end up with an answer of 1.8 times 10 to the 24th tacos. There we go. Okay, next question. Starting off with the next one, it says, what weighs more, 0.058 moles of oxygen atoms or 1.2 moles of hydrogen atoms? Well, if you're trying to figure out which one weighs more, we need to convert each of these to grams and then compare and see which one's heavier. So, what do? Well, I can write it on this piece of paper right here. If I'm going from moles to mass, I have to use my molar mass. So moles of oxygen, multiply that by 16 grams per 1 mole, 1.2 moles of hydrogen times 1.01 grams over 1 mole. Moles cancel out, I'm in grams. So 0.058 times 16, that's going to be a very small number. 1.2 times 1 stays about 1.2, which is a bigger number. So we have a greater weight of hydrogen atoms. It weighs more than the oxygen atoms. Let's double check this. Just always double check your math. 0.058 times 16. That does give you a number smaller than 1. So this is greater than 1, so hydrogen does weigh more. Number 9, how heavy is 1 atom of iron? That one, again, would be 2 steps because you have to go from particles to mass. Here we go, 1 atom, changing it to moles, canceling out with Avogadro's number. See how Avogadro's number is labeled correct in atoms. Then multiply it by its molar mass. That looks correct. Again, we have a problem with scientific notation for it. Easy to fix, just make sure you type it in correct on your calculator. That would be 1 divided by 6.022 times 10 to the 23rd, so divided by that, then multiplied by the molar mass, and you get a number that is 9.27. Got to round it to 2 sig figs, so it ends up being 9 times 10 to the negative 23rd grams of iron. There we go. Last question is a lot like, I believe, number 8. If there's 4 grams of lithium and 4 grams of calcium, will they have the same number of moles? Well, the answer is no, because lithium, if you look at the periodic table, I believe it's 6.94 grams of lithium is equal to 1 mole. That's how heavy 1 mole of lithium is. Calcium, 1 mole of calcium weighs 40.08 grams. So if I have 4 grams of lithium and 4 grams of calcium, you'll have different numbers of moles, because when you do your mass to mole conversion, you'll actually end up with way more lithium atoms than you would calcium atoms, or moles, I should say. And the same for atoms, because if you have more moles, you have more atoms, and you must explain this in words. So unfortunately, this was not explained in words. You have to explain it in words using the concepts. The math does appear to be correct, though, so that converting to moles, comparing the moles, then converting it to atoms, that looks about right. All right, if you have any other questions about these problems, you need to come to tutoring. Tutoring will be this Tuesday, coming Tuesday after school. Thank you.